we have f of x equals 2e to the 3x, and this is going to be on the closed interval -2 to 1/2. All right, first thing we do, take the derivative, f prime of x equals, we keep this the same, multiply by the derivative of the exponent, so we have 6e to the 3x. All right, what do we do next? Well, we set it to 0. All right, is there anything we can put in x so that this will equal 0? No, nothing. So there are no critical values. No critical values. So when there's no critical values, we're just going to look at the endpoints. All right, so f of -2, we put into our original equation, and that is approximately 0.005. Then we take f of 1/2, which is the same as 0.5. And that comes out to approximately 8.963. So now we can state our absolute max is 8.963 at x equal 0.5. And our absolute min is 0.005 at x equals -2. So those are our answers for the question. Okay, we have another theorem and then another example, and we're already done with this section. That was quick. Okay, so here's another theorem. We just call it max-min. Max-min theorem. And it states, if f prime of x exists for every x in an interval, and there is one critical point, not point, sorry about that, critical value. We're going to call that C. Then f of C is the absolute max if f double prime of C is less than 0. And that makes sense. What do we know when f double prime C is less than 0? We know that it is concaving down, right? So there would be a max right here at f of C. Also, it states f of C, I wrote x, f of C is the absolute min if, what do you think? You are correct. F prime of C is greater than 0. And that makes sense because when f prime of C is greater than 0, we know it concaves up. So f of C is the absolute minimum. That would be f of C. So let's do an example using the max-min theorem. Okay, here's the example. F of x equals 4x minus x squared. Okay, now in order for the max-min theorem to work, I'm going to read it again. If f prime of x exists for every x in an interval and there is only one critical point value, then, okay, so we know this is continuous, right? All right, since we know it's continuous, we know f prime x is going to exist all over, actually any interval for here. So the derivative is 4 minus 2x. Okay. Now this happens to be true if we're looking at this function. We know from negative infinity to infinity, this is going to be just fine, right? We're not going to have any discontinuity anywhere. Okay, so we took the derivative. Now what do? We set it to 0, that's right. We solve. All right, x equals 2. All right, so now what do? We're going to put the 2 in there. F of 2 is 4 times 2 minus 2 squared, which is 8 minus 4, which equals 4. So what do we find? Well, we don't know yet because we haven't taken the second derivative. We have to take the second derivative. Taking the second derivative, we get minus 2. Minus 2 is less than 0. So what does that tell us about f of 2? If this is less than 0, then we know we are concaving down, and therefore f of 2 is an absolute max. So we state the absolute max is 4 at x equal 2.